Hello community, so great that you are back. Today we talk about the second step. We talk about here the very latest research from prompt optimization. And you might say, but why are we talking about this? Because in my latest video from yesterday, I was talking here about tool use for our LLMs in an agent, and I showed you with the right tool you can achieve a 100% causal reasoning performance even with small local LLMs. And you came back and your feedback was strong and you said, hey, okay, so with tool it works, but we want to see that the LLM is doing it. Because we have all the intelligence in the LLM. So you said, hey, come on, is there no way that the LLM without a tool use can achieve this for itself? So do we really need an agent, or is not the LLM intelligent enough if we do some tricks? So let's talk about what can we do, and there's a lot of research from yesterday about how to optimize here the prompt. And you know, for a long time it is not the human prompt, your human language that you speak, that is here the real input to the LLM, but we do have prompt optimizer for almost every global corporation. Let me give you an example by OpenAI. You notice the prompt generation, and you just give a description what you want of your task, and OpenAI generates the prompt for you, the functions involved for you, and the data schemas to have the execution of your task. And they do this with a meta prompt and meta schemas. And I also showed you this meta prompt. And I told you, careful, there are examples. Look, they say include high quality examples. And this is really helpful. And then they give you a lot of instruction. And they say, hey, and the final prompt should have the following structure. So details as needed, of sections, of headings, a bullet point for detailed steps, a detailed breakdown of the steps necessary to accomplish the task, plus examples. And you will see this also happening here with Google in the Vertex AI prompt optimization, or if you go with Anthropic for the prompt generator, there they tell us, hey, this prompt generator guides here Claude, so their own proprietary LLMs, to generate high-quality prompt templates tailored to your specific needs. And those prompt templates follow many of Anthropic's prompt engineering best practices. So again, you have a human sentence, but this human sentence is not the real input to the LLM, but it goes through a prompt generator, and they have best practice prompt engineering templates, and your human query will be translated in their template. But you know what? Let's go professional. What do you think about this idea? And I have here a beautiful study from Stanford University and UC Berkeley from 6th of October 2024, optimizing instruction and demonstration examples for a multi-stage language model programs. And you might say, hey, wait a second, what do you mean programs? Yes, this is the new stuff. So they say, hey, LLMs are cool, but you know, if we have sophisticated pipelines, we can decompose the complexity of a task in multiple elements in this pipeline, and then we probe each sub-pipeline with the LLM. So let's have a look at this. A little bit of a definition. What is a pipeline? In the context of a multi-stage language model program, a pipeline is a structured sequence of steps where each step is a separate language model call. A simple prompt designed to handle one specific part of a complex task, and the pipeline flows from one step to the next step, and each step's output becoming the input of the next step. Easy. So what we do, if you think about it, we just break down here a complex task into some smaller, easier, manageable parts for the LLM, making it easier to guide the model through the task. Great. Let me show you an example. I think we learn a lot with examples. So, to answer here a complex question that requires gathering of new information and processing of the information in multiple steps, we have an example: which Nobel Prize winner was also a well-known political activist, and what was exactly their contribution? So the simplest example I can think of is a three-step approach here. So step one, you search for the candidates. Now, you have an instruction given out to your LLM. I say, give me a question about a Nobel Prize winner and activism. Generate now the perfect search query to find relevant articles. And here now comes this idea that I showed you by OpenAI, provide few-shot examples. This is so helpful for the system. So here we go, example. Who was a physicist and also a novelist? And the search query for this particular example would be physicist and novelist for the Nobel Prize. So output defined. This here is what they call here step 1. Step 2 is now retrieve the relevant information. So using the search results, find more details about potential Nobel Prize winner who were activists. I give you another time here, a very simple few-shot probe. Nobel Prize activist contribution, sample response. Albert Einstein was a pacifist who advocated for civil rights, and we get an output of step number 2. If you read the paper, and I would highly recommend this, please note that those steps, they don't call steps, but they call module. Okay, step 3, summarize the answer. And again, we have an instruction, summarize the findings to answer here the original question, make sure to include both the Nobel Prize and the activism aspects. And then we provide an example here. Input, Einstein, Nobel Prize in Physics, activism in pacifism. Output, Albert Einstein won the Nobel Prize in Physics and was a well-known activist for civil rights and pacifism. So you see, you define here the steps that are necessary and you want that the system performs those steps. So this is, if you think about it, a chain of tasks. This is what is the core of a multi-stage language model program. So in the context of those, in this pipeline, each output model's result must be accurate and relevant, as errors can propagate and affect significant the subsequent modules. Think about this. We are optimizing this in each state, and we do this in a way that is proven successful, so we have instruction and examples. Instructions, simple. We're tuning here the word or the phrasing of each prompt so that the language model understands each task requirements better, easier, faster, higher quality. Plus, we add examples. Future demonstrations, ICL, in-context learning, you know this procedure, providing here high-quality examples at each stage to show here the LLM the type of response we are looking for. And this helps here the LLM, as I showed you with OpenAI models here, to perform better. So, but now careful, there's a high sensitivity. The challenge is that adjusting just one prompt here in this chain of modules can affect the whole workflow, making it difficult to figure out how each individual prompt contributes to the final task success. And how to figure out how to optimize this system, because what we have is, if you want, kind of a waterfall principle, no? We have a real complex task and we break it down into simpler tasks, and we have here in the instruction, we have a prompt and an example given. And this is now for a low complexity task. And then the output of this is the input of this, and then we have a prompt and an example, a prompt, an example, a prompt, an example. We decompose the complexity into simpler tasks, and output becomes input, and you get the idea. Now, if here somewhere the prompt is not the perfect prompt for this particular subtask, this error will just propagate and destroy our complete chain of tasks. Great. Key insights from all of this, and particularly this study, was that Bootstrap few-shot examples significantly enhance the task performance across all the stages, highlighting here, especially here for this prompt engineering, the importance of examples and the high quality of the examples. Plus, the second was that it is a joint optimization. So we have a joint optimization of the instruction level and the high quality examples. And if you have both right, this provides here the best results, especially if you have complex NLP pipelines. Isn't this great? And they also wrote here an optimizer, they call it MIPRO, Multi-Prompt Instruction Proposal Optimizer. And this is simply an optimization algorithm designed specifically for improving the performance of multi-stage language model programs. So we are not talking about anymore here about prompt engineering. We have it now outsourced here to programmatic structures. And you find this here at Stanford, NLP, DSPy, together with all the other notebooks. They are beautiful, available. And if you were there, you see just a short time ago, they optimized here also the multi-agent DSPy program for bootstrapping and aggregating multiple React agents. This is a beautiful piece of code. This is a Python notebook. You can download it for free. So go there, have fun, experience it yourself. Now, going now the next step, because we want to go here to the fringe of our knowledge here. There is now an interesting idea to reverse engineer an LLM to understand its inner workings and then optimize here the prompt structure, the prompt programs in a way that is here taking care about how the inner workings are. So we optimize a prompt given our knowledge of the internal structure. And we have here publication 8th of October 2024. And what they do here, they, in my words, reverse engineer OpenAI's O1 model. Highly interesting to learn what they did. They have here a real journey. This is part 1. Part 2 will be published soon. And they describe what they found out. So they probed here OpenAI's O1 model and they tried to understand how does it work? How does it think? How does it reason? And they started here with a very simple process. They tried everything from tree search, multi-agent, human sort, proposed critique loops, how to improve this. And they just probed the system. They probed the system continuously. And they built here a timeline. It is so beautiful. And you see, they had more or less 4 ideas. The attempt 1 was here, propose here a critique loop, or a tree search with LLM and a reward model, or a multi-agent approach, or complete a human sort documentation. And you see here, attempt 2 seems to be real interesting because they developed here the reasoning tree structure and the long sort ideas, what they built. So a lot of things, training, post-training, SFT from Hugging Face, DPO here as our fine-tuning methodology, human jack. So they want to understand here, how does it work? How can we optimize the prompt structure? And then they had, of course, problems. No, they had tasks to understand what is going on. And they published one of their tasks where they say, hey, those tasks provide us insight. Now imagine you have 2 global corporations and you want to understand the inner workings of your LLM, of your competitor. Interesting ideas, no? But we are here for research, so look at this. You know what this is? Look at this here in detail. Solving the equation. Define the roots, therefore construct, analyze. So we force this pure LLM, this little kind LLM, to do what? To have here a mathematical solver for equation. Now, going back to my video of yesterday where I told you, hey, we have so many beautiful tools where we have Python, Prolog, Go with Scala, C++, whatever you have, no? And we have so simple but beautiful Python code to solve this equation. So tool would be the perfect, intelligent way to do this. But okay, if you want to force the LLM to do this, and I told you in the video yesterday, what is the error rate? It goes down to 20% performance of the complete LLM. Okay, so they tried to do this. And I have to tell you, if you look here at the performance by Chatbot Arena, if you look at all the different LLMs and VLMs, and here you have here style control, the hard prompts, the instruction following performance, the pure coding performance, the mathematical performance, the multi-term performance, the long query performance, you see with OpenAI's O1 preview, currently September 27, 2024, the best model overall with 1 is O1 preview. Beats any other model as voted by the AI community globally. So yeah, but this only means that from all the available models, O1 preview is the best one, but it doesn't mean that this has also the best performance. I mean, 100% performance. So careful. Plus, if you look here, and this is a video I did about customer relation management, AI agents, you know, Microsoft will publish here in November this year 10 new agents for financial AI agents for really sensitive topics. And if you ask me, do I want that Microsoft agents do the calculations within the LLM or within the tool? I think even the exact Excel tool from Microsoft, I would say, yeah, okay, yeah, I know it works, Excel works. Or you might say, hey, maybe they do here a Python environment and say, yes, beautiful, gorgeous for financial calculations. Let's go with here a Python environment. Where I would be hesitant and I would not like it if they would tell me next month, we just do it within an LLM, we do all your financial calculations. So you should be careful and you should understand what company is doing what, at which particular tool, at which level our calculations are performed. And maybe it is not a good idea to put everything into an LLM. Hey, but next month I can show you here Microsoft, the agents, when I know exactly how they do it. Okay, let's go to the next step, because there is now a brand new research by IBM and UC Davis. And you might say, what is left? What can we theoretically optimize on our prompt further? Well, you're not gonna believe it. There's the idea that we have here a complete prompt program language, a prompt declarative language. And you say, wait a second. So I am, as a human, I formulate here in the human English language, for example, my task. And the LLM, to have a high performance, now suddenly says, hey, buddy, I can't take your input as a human. I need now a new descriptive language to transform the human sentences into something that is optimal for me as an LLM, because I'm not allowed to use the tools? Yes, this is the idea. So here we go. Here we have October 24, 2024, a beautiful new study, PDL, Prompt Declaration Language, a complete new prompt programming language. And you might say, my goodness, this must be beautiful. No, it's for everything. It is for Chatbot, it is for RAG, it is for agents, it is whatever. Now, this is an interesting idea if you think about it, no? Because IBM tells us, and you know that IBM has their own models, LLMs, and now they have also their own prompt optimizer, like OpenAI has it, like Anthropic has it, like Google has it. Now we are talking about IBM, and they choose now to write a complete language, a programming language. Now this PDL is a declarative data-oriented language that puts prompt here at the forefront, but everything is based on YAML. So it supports writing interactive application that calls the LLM and all the tools, and it makes it easy to implement common use cases such as chatbots, the RAG, and our AI agents. Now, if you're a little green grasshopper, YAML is a data serialization format that is both human readable. This is nice. We get an idea if you look at the code, but it also provides you a structure by being a JSON compatible format. The variables here in this new PDL also can hold JSON values and can optionally be typed with a JSON schema. This is nice. We are compatible to existing knowledge. The program comprises here blocks, those are YAML objects, where each block appends data to the prompt context. And this is now a natural fit for the prompt techniques such as chatbot or agents, because the program execution implicitly builds up a conversation or a trajectory like we just have seen with our pipelines without necessitating explicit plumbing. And as I already just shown you, the context then becomes the input to the next LLM call. So we have, in theory, the same idea like I showed you before. What a coincidence that I showed you this before. But now here in a programming language. Now, the nice thing by IBM, it is open source. And here I show you the GitHub prompt declaration language. We have here an Apache 2 license, open source. And just last week, there was the new release of the latest version, 1 hour ago. Okay, and I asked myself, wow, should I take now this burden to learn another programming language? Yeah, So I ask here simply because I am lazy. I ask here my ChatGPT O1 preview, hey, for my green grasshoppers, I need to understand YAML real fast. What is the best way? Show me the most important things. So just for you to read, understand what is YAML, why do we need it, the main concepts of YAML, scalars, sequence mappings, the syntax and the features, comments, key value pairs, the mappings, the list, the nested structures, the anchors, the aliases, the multi-line strings, the folded block, inline collections that we have here, beautiful. And here a complete example. Suppose you are configuring here web application settings. And this is easy done. The server, the database features, sequences, supported formats, scalars, true, false, whatever, and strings. So YAML is a powerful, flexible format. We have it for data serialization. It is simple yet expressive. It is ideal for all our configuration files. We use it today in AI and for data exchange. And yeah, it makes sense that this is the basis for a new, if you want, prompt declarative language. I'm fine with this here. Beautiful. Yeah, simple yet powerful new language for LLM prompt. And forget engineering, we are now in prompt programming. But with YAML and PDL, you bring a little bit of the power back to the coder itself. Because remember, our alternatives are only machine automated versions. Like I've showed you here with DSPy. This is more or less a self-improving machine learning system where the machine optimizes itself by Stanford here in this video of mine. And then I showed you we have even something more up-to-date, something better, a high-performance system. It's called TextGrad in this video, also by Stanford, but performance is better than DSPy. And then if you want, we have now a third option now starting today or yesterday with PDL, LLM prompt programming. So we have more or less 3 methodologies of prompt programming. This is what I thought, but no, I was wrong, because reading this and having a look here at the real code, and here you have a simple chatbot in PDL. So you see here, those are the commands, and I just started learning yesterday, so I'm not an expert at all. I'm a bloody beginner. I can tell you, I just want to show you here that you get a feeling how the code looks. And there is here my quick reference. This is my cheating something, that I have an idea what is going on, what are the command structures, what types I can use, what expression I can use with my values, my operators, my filters, and so on. So yeah, it is my first day. This is all I can tell you. But the nice thing is PDL comes here with tools for making here the programs easy to write, to run and understand. Just to tell you, you have an interpreter, you have an IDE that supports here VS Code, you have Cell Magic that enhances here our Jupyter notebooks for developers who write in Jupyter. We have a live document visualizer, we have a software development kit, especially for Python. And you know, a PDL file can contain Python in the code blocks. Just to give you here a hint what is coming, if you want here the complete RAG example in PDL code, here you have it in Python code. This is PDL to give you a feeling, and it's also where I try to learn and understand what is going on here. Plus, if you have a React agent, here you have the new React agent in PDL. And of course, you see optimized here for IBM, for Watson, IBM Granite, the 3.0, the new models, 34B code instruct models. Beautiful. So I think PDL is a real beautiful new language for LLM prompt programming. So you have more control as a coder. You have more down-to-earth commands that you can code. But honestly, for me, the question is, do I still want to learn a new language? Do I want to code everything again? And why not use here the autocoder AI systems? There's another idea. In this video 2 weeks ago, I showed you here, Stanford and OpenAI. There was this idea that the LLM codes here a controller, an intelligent shield in front of the LLM. So all the tasks, the queries, the data, and the tools come in. But Stanford decided here to build something like a new logic control interface, a kind of protective shield. before allowing everything into the LLM. So if we would place it here, it's brand new, but there's some great ideas how we can implement this even in the next step implementation phase. But yeah, more about this in a later video. What I wanted to tell you here, what the authors think about it. Because they compare it now, as I told you, to DSPy, and they say the DSPy prompting framework has a tagline of programming, not prompting, yeah? It finds the prompts automatically. So the authors say developer need not to write them by hand. Now this is either good, or you like it, or you do not like it, whatever you do. And of course, there's also parallel to DSPy, you have here Viera. It kind of extends here Prolog with LLMs as a probabilistic relation, which automatically here derives here also the prompts, So with either system, if you're not familiar with the second system, I was not familiar with the second system. I learned a lot by looking here at this publication, Relational Programming with Foundation Model by those authors, University of Pennsylvania. And they propose here Viera, a declarative framework that unifies the mechanism in a general solution for programming with foundation models. Follows a probabilistic relational paradigm and treats foundation model as stateless functions with relational input and outputs. You have neurosymbolic applications and beautiful. So wherever you want to go with what model, there are now a lot of possibilities for you. And of course, as the authors tell us here, there's a new crop of prompting framework based now on agentic system. And the author of the study tell us here, so IBM and UC Davis tell us here, they focus here on 3 points here, autogen, a multi-agent framework. Then they say they also looked at Crew AI and GPT Swarm. So they say, okay, but in general, their judgment is that PDL supports agent as well, but it aims more of a balanced stance where agents are just one of many prompting techniques. So it is up to you. Do you want to go and focus only massively on AI, autogen, Crew AI, GPT Swarm? Or you want to have more of an LLM prompting technique, then maybe here PDL might be an option for you. So I was asked to give at the end of my video something new, maybe a personal reflection. So I think that if you are working within the IBM ecosystem, if you are using IBM Granite 3.0, LLMs, whatever, then maybe it is a good idea to learn here the complete PDL code syntax, because you will need it for your models. Or, and this is what I'm looking for, so here you have IBM Granite here, you have here everything is available on Hugging Face, you can run it locally with Ollama, this is beautiful, and of course they trained all their models here to understand here PDL. Of course, great. Now I don't know, I haven't tried it out, I just discovered it yesterday, how good are other LLMs in understanding here this particular declarative language. But for me, it just appeared yesterday. So I can't tell you here any experience as it's much too early, but if you like to try it out and give us a feedback here as the AI community, I would highly appreciate if you leave here a comment. Another option is, of course, I do not learn here the complete code by myself, but I say, hey, we're in the age of AI, so I put all the cookbooks and every documentation about here the PDL code and everything that there is available, and I try to program here a code LLM. Now, as it turns out, and I'm looking here at my training data, that there are not so many examples yet available on the second day. So I don't know if my new code LLM, it is currently running in the background, will be able really to come up with some reasonable logic PDL code. I can't tell you today. But, and this is what I'm personally thinking of, I've heard that DSPy 3.0 is coming soon by Stanford University. So I think I'm not into the Granite IBM ecosystem. So maybe I will wait and have a look at DSPy 3.0 by Stanford University. And I have high hopes for Stanford University. before I decided I have to enter here IBM ecosystem. But hey, what do you think about it? Are you an IBM ecosystem user? So this brings us to the end. You see, this is where we started with a human prompt. Today, no human prompt goes through to an LLM. You do have from the great corporations here specific for their proprietary system prompt optimizer. Either it's template, either it's an instruction, whatever company you choose, from OpenAI to Anthropic. And today I discovered something new yesterday, and I want to share this with you. This new idea of a prompt programming language. We had DSPy, we had TextGrad, we had different system, but IBM developed their own program language for the prompt programming. And I think, wow, so now we move really in the complexity up, because now we have whatever is my human sentence. Then I have to translate my human sentence in a prompt programming language. And then this prompt programming language will enable the LLM to perform here a task. And I just can hope that with this prompt programming language, the task is now so clearly defined that the LLM will also become good in causal reasoning, spatial reasoning, mathematical performance. Otherwise, the video of yesterday, it might be a good idea just to take your old LLM and use the right tools, either Python, Prolog, Lisp, Scala, C++, whatever you like, with function calling, API, use all your databases you have. So it is completely up to you what you want to choose for your particular problem, but I think I've shown you now, you have now two options. LLM with tools, or if you say, no, I insist that the LLM has all the mathematical reasoning, causal, spatial capability, and I just want to go with prompt optimization to the extreme. Prompt programming language is the latest that I found in the AI research literature. I hope you had a little bit of fun. I hope you had some new ideas. I hope you maybe would like to try out something completely new. And it would be great to see you in my next video.